Okay, I'll show you a couple resources. So we'll talk a little bit about databases and SQL today. By popular demand, this is what people seem very interested in, and it's definitely relevant to what we're doing. So Nick Yule and I did this SQL workshop last year. We did it for the business students, assuming no knowledge whatsoever of SQL. You are more sophisticated than a lot of this, so yeah, I mean, I'll talk about the ideas here, but feel free to jump in and work with this data. So we've got a little stocks database and a bunch of questions that you can check your answers to. And I think, well, I could put a link to the answers, but I think you just add answers to the URL or solutions and you get the solutions. So that's our trick. But yeah, go ahead and check that out if you want to know more about SQL. We can't really, I don't have time in this class to really cover everything that's in SQL. But if you really want to know more, then there's this Stanford's free online database class. This is actually how I learned it, and I think it's a great class. It really goes over the core concepts, relational algebra. So if you're going to be a data analyst or data scientist, this stuff, I consider it completely essential material, and you can go through this and check it out. One more book I recommend for this. I almost made this a recommended reading for this course, but it's Designing Data-Intensive Applications. It's got a big overview of lots of the ways that people use these distributed systems, and it's really helpful for understanding how it all fits together. And we realize that a lot of the stuff that we've been doing is kind of niche with offline data analysis. But as far as how big companies like LinkedIn and Facebook and Amazon work, it's all kinds of really cool ideas inside here. And I've got links to all this stuff on the lecture notes. Okay, there were some questions. One of the questions was what resources or what do these things actually mean? What do any of the columns in the database actually mean? So we've downloaded the database and I don't know what they mean without looking at their documentation. So besides the index, there's also this data dictionary, and this is the first place I would look. You can see the answers inside this Piazza post here. If you want to get more into it, something a little deeper is this schema. And if you click through some of these things, you can actually see the relational database model that they put up here and kind of figure out how everything relates and what it all means. So these are some resources to check out. Rodrigo, does that answer your question?
Yeah, we just found it.
Oh, okay. All right, cool. So yeah, Piazza. Good stuff.
I mean, someone asked this in GIPSA is between pop and recipient.
Pop and recipient?
You answered that. So you said, so it means place of performance. Pop means place of performance.
Oh, okay.
We just found it.
Place of performance.
Yeah, right. I don't know what it means exactly, but like the...
Pop, place of performance?
Yeah.
Found in data dictionary.
Yeah.
And recipient should be who received the funds. Yeah, Jared?
I remember, I don't know if it's the same link, but I went to the USA Spending at Common Data Dictionary, and it's like a really big dictionary. Like, it's not just our data set, it's like other data sets.
Okay.
And so we like scanned our column names to the
You mean of the column names that appear as variables? Yeah, and even if they do, you're not guaranteed that they're what you expect they are, right? They could just happen to be named the same thing. So this is an issue in databases in general. So I don't have any good advice on how to get over this thing other than search the best you can and use something with common sense. I mean, I don't think it's particularly critical that you know what every single thing is, right? It's enough to know what most of these things are.
I think some are quite necessary, others are ignorable.
Yeah. Yeah, so in case you're doing a project where you're using some kind of machine learning, if there's some question about what something means or not, then maybe just leave it out. That seems like a safer thing to do. Okay. Wanted to get a little review in real quick. So last time we talked about test-driven development. I think it's different.
Light? No, just
Can you see that? Yeah? In the back? Can you see? Okay, good. So we talked about test-driven development. Remind me what the idea was?
It's kind of like a philosophy, right?
It's a philosophy. It's a way of life. Test-driven life development. Okay. And what was it, though? Write a failing test. And then? Huh? Go home. Go home, come back the next day. Write the minimum amount of code to make it pass. Okay. We also talked about profiling. And what was the idea of profiling? Big idea? Yeah. So run it and measure it. Find out what's slow. Once you figure out what's slow, you make the slow part fast. And then repeat. Repeat until it's fast enough. That was the idea. So ways to make things fast. We already know, we saw parallelism. I spelled that wrong. So hard to spell. Parallelism is one option. Might make it faster. What else? What did we do yesterday? Not yesterday, last lecture to make it faster? Yeah, switch data structures. So just to be clear, the problem yesterday, we started with the data structure that made sense to us in our computation, and we determined that it was actually causing a bunch of overhead. So we swapped it out with a simpler data structure that did the same thing, but had less overhead associated with it. But by changing data structures, you can get huge speed-ups. What's an easier way, possibly? Vectorization, yep. What's even easier than that? Huh? Buy a faster computer. Bigger. Usually bigger is what we want. Bigger, faster computer. Yep, another option. What? Change the algorithm. Yeah. So maybe that's kind of like change algorithm. Right, yeah, we should kind of organize these and how important they are. I don't know what's what's most important. They're all viable options. There's a couple more I'm thinking of. So what's really easy? What if someone else already wrote a really fast version? Use other people's fast code. So if someone already implemented something in C and it does what you want and it does it really well and fast, then just use that. And there's so many things that are like this in R, like reading files with fread is really fast, converting dates with fast POSIX CT is really fast. You don't have to struggle with that. Other people have solved it. And there's another one that's kind of more extreme that we haven't gotten to. We might do it one lecture next week. Yeah?
Use optimized builds of R Python.
Okay, so that's kind of like in terms of buying another computer, it's like get better versions of the software.
Oh, we don't.
Yeah. Some you do though. Get faster versions of software. And one other thing was interfacing to a compiled language. Interface to compiled language. So this is more if you're like building a library that you want other people to use and use a whole bunch. Another option. Okay, any questions on what we did before? Questions in general about the project, things to do? Okay. Yeah.
It's fine if we do it in like multiple languages and post it to report on Microsoft Word.
Can we use multiple languages?
Because like we thought like it'd be good is there's just three people in it, right?
Mhm.
Like it's hard to like start from square one and move forward together because one, we don't really know much about the data set because we haven't really done anything. And two, like we have different understandings of material, so we can't really move to like lockstep.
Yeah.
So we figured it's a good idea to split and just do the question on our own and mix from all together again.
Okay.
And try and develop an analysis based on that.
Yeah.
So in that sort of part, like we want to center around questions, topics, and solutions rather than discussing how our code like evolved from loading the data to like modeling, you know what I mean?
Yeah. So I think that's totally fine. I think that's totally viable approach. And also, what you're talking about is breaking it up into little pieces, right? Or giving each person one task and letting them do that in whatever language or technology they want. I think that's fine. We've mixed languages in this class, and that's all good to me. Yep. Yeah. Use whatever you want. Okay. Databases. So start off with a question I want to ask you. I want to see what you think. What is a database, and how is it different from a bunch of CSV files in one directory? In a directory. So with this class, we've been messing around with these huge CSV files and learning techniques to process them. But if we just threw a bunch of CSV files into a directory, that's kind of like a database, right? So, yeah.
Databases are often managed.
What's
They're
that?
often managed.
Managed.
So controls like storage and concurrent access.
Okay. So, externally managed. Yes, somehow managed. And what managed? What does that mean? Controlling access?
Yes, there is a process that controls access and handles the storage.
Access and storage. But file systems are managed too. I mean, we have some control over access, not the same way. I guess if you could log into it.
So like how do you do concurrency with that? Or you could
Yeah. So concurrency means having multiple users at the same time.
And it also optimizes for the type of data.
Yeah, type of data. So this is a concept that's pretty important.
So if you like select from Postgres, it's often going to be faster than selecting from a CSV file.
Definitely. So the color chart. So an important term here is schema. A schema in a database, it just says basically what kind of data can live in the database. What kind of data is allowed. So when you define a schema for a database, with a CSV file, you can just put anything you want, anywhere you want, essentially. It's just plain text. You can do whatever you want with it. There's no restrictions at all. You can have a whole bunch of numbers and then suddenly put text in that column, and now the column is text. With a database, you define ahead of time, these are my tables, these are the types of each columns that I want. And by the way, I'm using the word tables, so I should write that down. A table, we can think of a table as just a collection of rows and columns. So where do we see tables? And where are we familiar with them in the languages that we've used already? Yeah, so in R, we have a data frame, right? Pretty much the same thing in SQL. The difference is that in SQL or a relational database, there's no concept of ordering the rows. They have no order. In an R data frame, they have an order. That is, there's a first one, and a second one, and a third one. In an SQL relational table, there is no order. There's no order of the columns either. It's just how you write your query. You can write a query that puts the resulting output in an order, but that's a little different.
So if you like looking for columns by number, like sometimes we do in R, you won't be able to do that in SQL.
You cannot do that in SQL. There is no number attached to any row.
Like an index.
Yeah, but you can add an index. That's something I should point out. So there's something called an index. So an index in a database is a data structure that allows you to quickly look up rows based on the value of a column. Let's write that down. Based on column. Okay, in the CSV files, we have this huge transactions.csv. If we want to find all the ones where the recipient belongs to a particular recipient, how do we find them? All the rows that belong to a particular recipient with our CSV file. Is it fast? Yes?
Just like this.
Yeah, so you could pipe through and grep and do these sorts of things, but what it requires is a full table scan. We have to look through every single bit of data because we don't know anything about the structure of that data. If we knew that it was sorted by recipient, then we can get clever, possibly. You know, we can do like a binary search and search for it, go to the middle of data and try to find it here and there. But an index in a database is a structure that lets you jump right to that row, the row that you need, and look it up very quickly. So you get very fast lookups, order one, kind of like a hash table. Okay. So with SQL or a database, we have something called a query. And all this is selecting data. A query is the thing that lets us pull data out of the database. And I should write down what SQL actually stands for. Do we know?
Structured query language.
Structured query language. Query language. Lots of terms. Any questions on those? And those, by the way, are kind of the advantages of a database. I thought this was pretty interesting. So this paper that came out in 1970, E.F. Codd was working at IBM. And he wrote this paper, and in the abstract it says, future users of large data banks must be protected from having to know how the data is organized in the machine, the internal representation. Activities of users at terminals in most application programs should remain unaffected when the internal representation of data is changed, and even when some aspects of the external representation are changed. Changes in data representation will often be needed as a result of changes in query, update and report traffic, and natural growth in the types of stored information. Then he goes on to say what this paper does, it's a model based on in-array relations, a normal form for database relations, and the concept of universal data sublanguage are introduced. So this was the SQL language that he was talking about, relational algebra and the SQL language. And he outlined all this stuff in this paper in 1970, almost 50 years ago, and it hasn't changed since. That's it. Like, he just nailed it right on the head. Yeah, he totally got it. And right now we have this thing, tidy data. We've used the tidyverse. People use the tidyverse in R. So the whole idea is to put your data in third normal form. And the idea is exactly the same as this original data idea that came out in 1970. It's just, it keeps applying because it's a really good idea. So I have a link to that paper, and I encourage you to read it. It's actually pretty accessible, I think. Okay, so let's talk about how the systems actually are in place, what databases are used for. So often we have this client-server architecture. We've seen this before in what we have done with the cluster. We have one cluster and many users. We're all using the cluster at the same time, and other users across campus. The idea is the same with the database. We have one database server that serves an entire organization, thousands or millions of people in an organization. And everyone has their client, and they kind of connect to that one database and access it like that. So if you get a job as a data analyst or a data scientist in an organization, then you want access, direct SQL access to these databases that are behind the scenes. This will let you be more effective and understand what's going on. And believe me, if you can do everything that we've done in this class already, then you can definitely do SQL. I think SQL is a step down from all the stuff that we've been doing, but you can definitely handle it if you haven't seen it before. So learn it and use it. And I think SQL, it was designed to be straightforward for business users to grasp. And the reason is SQL is what's called a declarative language. Declarative language. And this means that you say what you want, not how to compute it. So with SQL, you say something like select this column and that column from this table where these conditions are met. You don't say loop over all the rows in a file and check the value of the 18th column and see if it's equal to this string. This is imperative style of programming that we are familiar with. But declarative is just like you specify it. I don't care how you do it. Hopefully it's efficient, but you go do it system. That's the idea. One other thing is an ad hoc query. People will say this, worth knowing. If you're a data scientist or a data analyst and you're just pursuing some particular question, you just write a one-off query. So you write one thing to use one time to answer one question. That's what people mean by ad hoc queries. Okay. So you'll find two types of databases in large organizations. And this is just kind of a rough characterization. You have something that's called a transactional database. So these are for when you make a bank transaction. Make a bank transaction. When you buy an airplane ticket, book a hotel, buy life insurance, these sorts of things. All these things are stored into some kind of transactional database. So these databases are the lifeblood of these organizations for the most part. Like they protect them like crazy. They won't just let you fresh out of college go in and start writing your R script on these databases that are worth billions of dollars to them. You probably won't be messing around so much with these because the stakes are extremely high for getting it right or wrong. It's worth so much money, all the orders and stuff. So more likely you will have access to something that's called the data warehouse. So often data will flow from a transactional database into a data warehouse, and then this is where they maintain long-term records of a whole bunch of things that have happened in an organization. So this is also called the enterprise data warehouse or data lake. Any other terms? Data swamp if it's a poorly maintained data lake. Lake swamp. And people just use that term to say, like with our data, what do any of the columns mean? We don't know. It's just a whole bunch of data. Hopefully you can figure something out about it.
Data dictionaries for the.
It depends. It really depends. I mean, if it's like a transactional database and it's worth a lot of money, then of course they will. At least someone in the organization will know what the things mean. But often that knowledge stays siloed. So only one person will know, and that's kind of their job, so they don't really want everyone else to know, because why would they have a job? or something like that. Yeah, I don't know. I'm a big believer in free knowledge and distributing it, but often it gets really complex too. So not to diminish the complexity of the whole organization, because like at Cisco, for example, these transactional systems, we have probably 30 or more transactional systems dumping into one big data warehouse at the end. And to know what all of these things mean is really hard. So. So we talked about the client server, but today I'll show you SQLite is file based. So that means just one file contains the whole database. You don't have to set up a client server. We're not all necessarily using the same database, although we could all read the same one on the cluster and that would be fine. And I'm doing this basically because it gets you started quickly. Okay.
This means we have local copies of the database.
Local copies, yeah, you can download that from the website. Right. Anson. Right here, this SQLite.zip. We download this, unzip it, and I noticed one of the questions on Piazza was trying to do a word count on it. You can't do, like WC, you can't do word count on this because it's a binary file. Everything is stored in some particular format that's specific to SQLite. You can't just loop over the text, although I'll show you how to turn it from that binary format into text. I'll show you that here. Okay, there are tons of databases out there. What are some people have heard of?
Google
BigQuery? Google BigQuery? It's a cloud-based one, right?
Yeah.
So what other cloud-based one is there? Amazon has something, I'm sure.
You have tons.
Hmm.
Amazon has like 20.
Yeah, Amazon has like 20. Okay, 20 Amazon. Cloud-based databases, okay. That makes it complicated. What else? SQLite is one we're using. Any other ones? Big names in databases?
Postgres.
Oracle, yeah. Postgres. Hadoop, yeah. Hive, Hadoop. Yeah, Hive is the SQL layer. Or I think there's also Shark, Impala, maybe. Shark, Impala. Spark. Yeah, Spark is somewhere in there, in the Hadoop and Spark stack. So there's Teradata is another one. Other ones? Microsoft, yeah. Microsoft SQL Server, right? I heard something really interesting. That's the entire Stack Overflow site is served by Microsoft SQL Server, like 1 or 2 instances. They serve the entire website and make it run. Pretty cool. So some of these technologies are super powerful. You can do things like that.
DB2.
DB2, IBM. Okay. What else? MySQL. Let's capitalize. Anyway, point is there's a whole bunch of databases. Tired of them. So what they all have in common, almost all of them use some form of SQL. There are minor variations in each one. And sometimes they would have you believe that these minor variations make them completely different and so much better than everything else. Maybe they have better features, But the point is, if you know SQL, then you can pretty much get started on any of these databases. So knowing SQL is your gateway into using any of this kind of stuff. I think it's essential. So all, probably, use SQL with minor variations. So let's demonstrate it. I can use it from the terminal. I have SQLite 3 on my path. So I go SQLite 3 tilde data USA spending. USA spending dot SQLite. Okay. So with my, geez, what's this light? This is too bright. With my workflow, I've written this command in Bash, and just like I do R or IPython, I get a SQLite interpreter going up here. So this prompt has changed from my $sign for Bash into SQLite that shows me that I'm in the SQLite place. If you need help, you can enter just .help, I think. Let me try. Okay. So then you get all the different commands. I press, that is .help. So this .help and this .syntax, this is one of those variations that's specific to the command line version of SQLite. It's just to let you do a few convenient things inside here. For example, .tables. This is not SQL. This is a way for you to see what is inside the database. So you can do .tables to list those. .tables. And we see we have these tables inside our database. So a database consists of many tables. The tables consist of many rows and columns. People also say relational database. So these tables have relations among them. You can join them and synthesize and make new tables and that sort of thing. We can start using them. I can go select. What do I want to see? Top tier agency ID and name from agency limit 5. Okay. So this is a SQL query. Concretely, this is what they look like. Every SQL query has this. Select the names of the columns that you want from some table. The limit is optional. I'm only having it show 5 results because I don't want 10 million things to come rushing out to my screen. And we see that these results popping out here. So agency ID is 2, 3, 4. The name is Architect of the Capital. Yeah.
Is that the full data? Is that the full data?
Is that the full data? Yeah, I'm connected to the database that has the full data. Really quick.
Is that quicker than Bash?
So this is pretty much the equivalent of the command where you go head and cut the columns that you want. This does the same thing of the CSV file. So a lot of these things you can do the same way in SQL or in Bash or in R, in Python, many different ways to do the same thing. Okay, so the select from are the essential parts of a query. We also see this semicolon at the very end. The semicolon tells the SQL interpreter that we are all done writing our query. Unlike the other programming languages, it's not line at a time. It just waits until it sees that semicolon. Let's try. See over here we see this keep going, and then we have to feed it a semicolon to tell them we're all done, and then we see the result. Okay. So this way that I'm demonstrating of accessing the database, this will work on the cluster. You have this SQLite on our cluster on Gauss, and you just go module load bio to get SQLite 3 in your path, and you can start messing around and running big queries that take a long time. Yeah?
What is the name you do the query? You do like top tier agency ID and the name, or like
Top tier agency, comma, name. So in the select statement, I have all the columns that I want separated by columns, separated by commas. So it's a list of every column that I want in the order that I want it to. So when you write a query like this, the ordering becomes explicit. The database may have stored these in some other kind of order. You have no idea. When you write the query, it specifies an order.
Can we access SQL in R as well?
Yep. Let me show you how to do it. Okay. Good thing, because I did that. Prepared that. Okay. Alright, so you can mess around with that. When you're all done, you can do .quit to quit out of the interpreter. .quit. Okay.
Before you, is it faster to get the subset of the table in Bash and save it to a CSV maybe, and then get R to work on that file?
And there's a better way, and I'll show you. Yeah. Okay. But I want to show you this integration with standard out. So that was me inside an interpreter writing things, but a lot of the stuff that we've done was make these kind of cool processing pipelines where we're using a bunch of different technologies and moving them through standard out. So we can do that with the SQLite database. So I'm in Bash. From Bash, I can call the SQLite command, SQLite 3, header, CSV to give me a CSV file with a header when I'm done. The name of the file that I'm connecting to, data USA spending.sqlite. And then I can pass it a string that's the actual query that I want. And the query was this one. Let me just copy it. Select top tier 8. So it's the exact same query that I had before. So let's run this from the command line. Over here again, this is Bash. We're in Bash. I'm calling the SQLite 3 command. I get the result, which is this CSV file. It just goes rushing out to standard out. Okay. I could do the same thing and integrate it into some kind of shell processing pipeline. So here, instead of getting the first 5, I'll get the first 20 right here. And instead of stopping there, I can pipe it to head or pipe it to whatever command I want. Head, get the first 3. So in this way, these databases and things that we're doing, they can be joined in with everything else that we're doing, that we've done with the pipelines. You had a question in the back, David?
so that CSV converts the SQL query to a CSV
Yeah, so with the dash CSV flag, what I'm doing is I'm in bash, I'm calling the SQLite 3 command, I'm passing it the flags or arguments header dash CSV, and that's telling it to spit the result out to standard output with a CSV with a header file, essentially. Yeah. What is the header? The header, if we look over here at the result, it's top tier agency ID, comma, name. So that way, if we read it into something later with read.csv, we know what the header names are. They came from this query here. Probably if we drop the header, that will fall off, I imagine. That would make sense. Yeah, so now the header is gone if I don't pass that flag. As I expected. So this is one way, so you can actually write out the query inside here. It's not uncommon to have a really big query. For example, the queries that produce the data that you are analyzing are like 60 lines or more that I wrote. So you can have a query that spans 60 lines. You don't want to type all those into the command line. It's better to keep all those in a separate file. So we write our queries inside a separate file. So you open your favorite text editor, the best text editor, and you start writing a query. So I'll just call it query.sql. Okay, so this is just plain text where I can, it's a file called query.sql, and I can write into it. Select the same thing that I wrote over here. Let me just copy that. And because I like my SQL format in a certain way, I'm going to write it like that. Okay, so there's a file called query.sql. Save it. And the same way that I ran that query, I can pass in the query into that. Okay, so it's like this: cat my query.sql. So when I cat, it just shows me the contents of the file. I can take that and pipe that into SQLite 3. Okay, maybe it'd be easier if I, yeah.
You said that we have to upload the SQL file to the cluster. Is it already on there?
It's not there, but I think I should probably put it there because people will want to use it. I'll put it in Scratch in the same place that the other ones are. Oops. Okay, so let's try this. Right on. This to me is super cool. I'm sending standard in from a text file into the SQLite command, and it's producing the output in this way. Crazy way to use shell pipelines. But it's definitely better to be writing your query in a separate file. Then you can keep it independent from other things that you're doing. It's just a good way to organize things. Any questions on what happened here? Yeah.
The backslash, is that just to enter
Yeah, the backslashes here are just so I can get all my pipe things onto new lines. Yeah, I think the way that I had you do it before was to put the pipes on the end. I like this way better, I think, after staring at many of them. But either way, it's fun. Yeah. I'm not, and by the way, on the projects and things, I'm not going to like hold you to any of these very rigorous code standards. You do whatever you want and you think looks readable. All right. Okay, connecting to R. Questions on the command line usage? Move to R? Before we move to R? Okay. So why would you go directly between R or any programming language and the database versus making the data in some kind of intermediate form like a CSV? So why would you do that? So why go directly? Yeah.
So you don't download the entire thing, you just take whatever parts of the code you need to do some sort of.
So it's easier to stream in that way. Is that what you're saying? Potentially. Potentially easier to stream. But you could still stream with standard in and standard out, what we've done before. Or what we just kind of did, the technique I just showed you. You could still stream through that.
If you're saving intermediate files, you're using up memory space.
If you're saving the data files, yeah, so it uses less memory, yeah, more efficient. That's one less intermediate object that you have to make. That's true.
Faster.
Yeah, memory probably faster.
Well, it's almost faster. You don't have to string, you're like removing one extra step.
Yeah, yeah, removing a step should make things faster. Yep. But there might be weird cases where it could be slower. So most things come with asterisks attached to. few absolutes with this kind of stuff. But in my mind, the most important thing is it maintains the integrity of the data. So it maintains column types. So types inside a CSV file, this is the big problem. This is the database is solved. They put a schema on the table, so they say you can only have this type in this column. When you go directly from a database to a programming language, you translate one object from one type, for example, a floating point number, into a floating point number. It doesn't go floating point number into text, which is 16 characters long of text, and then back to a floating point number. You can actually lose precision like that. Or you can fail to infer the correct file data types. So this is a really nice thing. And you always want to go directly if you can. So just to be clear, it's better. All right. So most programming languages, they have an abstraction layer that hides the details of the database. You know how we've got 20 or more different database technologies? We don't want to write our R application to deal with whatever idiosyncrasies of the database are. It's just like what the quote by Edgar Codd in the beginning, you want to leave that kind of abstract. You want to be able to swap any kind of database into there. So in R, the tool for that, the abstraction layer, is called DBI, for Database Interface. Most programming languages will have something like this. In Python, there is, actually I think they have a DBI too, as well. They also have DBI, but they have SQL Alchemy is one. So it, regardless of the database backend, it does handles these things for you. Okay, and here's how you use it. We're going to use DBI and RSQLite. RSQLite, that one. Okay. So I start out making a handle to the database. This is some connection between my R session, my R interpreter, and the database where I want to connect to. That database is SQLite. and I pass it the argument to where my database actually is. Run this over here, con. So in general, when you have some different remote database, like a client server, you could have all your authentication inside here, like a user, password, where the host is. It's gauss.csc.ucdavis.edu or whatever the host name is, those sorts of things. But this con, nothing happened other than me going to the database and saying, hey, I'm here, I want to connect, I want to read some data. I haven't actually read any data yet. I've just established a connection between the database. So I could write the query, or I could just pull the query in, the one that we already wrote. Q equals read lines, what was it called? Query dot SQL. Let's see if this Q. I think I need to collapse it. Okay, pulling it all into one line so R doesn't get confused. So my query at this point is just a string. Now I had these first 20 lines that I was messing around with. First 20, I can actually execute the query on the database. So db get query, the connection that I have, the query that I have inside here. First 20. Look at my first 20. Oh, it should be called first 5. First 5, better name. First 5, okay? And then they come zooming over. They're, at this point, when I call the db get query, that goes and fetches it for me from the database. And if I look at now the class of first 5, it's a data frame, just like the correspondence between tables and data frames. I look at the structure. It's got an int and a character. So instead of reading the strings as factors like it does in the default reading CSV to the consternation of every buddy who doesn't want that to happen, it came over as the right data types. Okay. So I pulled the data directly in. When I'm all done, I can disconnect from my database. And that's db disconnect from my connection here. This tells the database that whatever has happened, I'm all done. You can wrap it up now. It's possible to leave things running. For example, I could have written like a whole bunch of data into the database. Instead of pulling it out, I can write it back into the database from R. And in that case, db disconnect will wait until everything is finished. And it will make sure that everything is done before it closes it up. And that's kind of important. Any questions on using R with SQL? So the workflow I've showed you is write a query in a separate file, read it into R, and then go execute it. Yeah.
I got an error saying that failed to connect to database, can't connect to MySQL server on local host 0.
Philip?
That doesn't say
So you're trying to connect to, his error says error can't connect to MySQL server on localhost. That means he's trying to use MySQL server, which he does not have running locally. Yeah. So MySQL server is another type of database. The one that we're using is SQLite.
Well, because SQLite, you know, SQLite's created, you can't use that.
You can't generally use different databases with different. No, like you can't use a MySQL database for a SQLite file. No, that won't work.
What happened to the database after you disconnect?
What happened to the database? So if I had made any changes, those would have been written to the file. Yeah. But I was only reading, so nothing happened. It's just like I read a CSV file. That CSV file is still sitting there. Yeah. Okay. All right, we got a little bit of, yeah.
Is there a way to write the query inside R script?
Yeah, that's no problem. So instead of that, I could have just said, let me grab my query over here and say Q2 equals this. So now I've disconnected from my connection, so I need to reconnect and try and run it again. And actually, I could just run directly. It doesn't really matter here. First 5. So that works. Cool. All right. I also showed you this DB browser. So this is a GUI that will let you experiment and see things possibly a little easier with the SQLite here. So what you do is you just open the database to the name of the SQLite file where you're at. You open that, and then you can start writing SQL over here to your heart's content. So this is an example of the SQL you might write, and I'm not going over the whole syntax of SQL. Maybe we'll do a little bit more next week, but I think you guys are pretty good at Googling and reading resources. Based on all your awk programs that I saw in that assignment, I think you can figure out how to do this sort of thing. Notable is the backtick I'm using. I still haven't renamed this thing from transaction. Maybe I shouldn't. So this backtick lets me use this transaction. This is a query. Essential parts select and from. I'm adding a condition where and limit 10. I can run these and see the results and see that they're reasonable. So this is kind of much more friendly than the command line version, I think. And plus you can browse around and see what kind of tables are in there. You got these 3. The join is where SQL and relational databases get all their powers from. I mean, this is what makes them really work. In one of the homeworks, I think it was homework 3, I showed you a lookup table where we had an agency ID with information about the agency. This is what a join is. We match based on the values of a column and select rows based on that to make a kind of a to pull columns from multiple tables together and bring them into one table. That's what a join is doing.
What type of a join is this?
If I don't give an argument to join, so they can be left, outer, or inner joins, it's an inner join. Yeah. So this is something called an inner join, and I have a little bit of time. Do you want me to talk more about joins, or do you want me to show you what a SQL injection attack is? Injection attack. I thought so. It's way more exciting than joins. Okay, so these are saved as examples in the examples directory, so you can check them out and play with them and tweak them, get them to work. Okay. So what is a SQL injection attack? I'll show you. There's a good comic for this. Hobby Tables SQL. Okay, so this is the joke of what a. Hi, this is your son's school. We're having computer trouble. Did you break something away? Did you really name your son Robert semicolon drop table students semicolon? So the statement drop table students will drop the table students inside your database. If you have a table called students, it will delete it. So you no longer have that inside your database. Little Bobby tables, we call them. We've lost this year's student records. I hope you're happy. And I hope you've learned to sanitize your database inputs. So this is exactly what a SQL injection attack is. So what I'm doing inside here, when I'm just writing a query, if I just use string formatting and let some user paste whatever they want inside there, that's when you're vulnerable to a SQL injection attack. So you write a query like this. Well, basically what ends up happening is they can write something like this. Q3 equals drop table agency. Something like this. And I think I'm connected to this database, so let me disconnect there. Okay. DB, and I think I need, instead of get query, I think I need sense statement. That probably should do it. Okay. Let's see if this works. Q3. Okay. Let's see if it did it. DB send statement, DB disconnect. I can check if it actually happened in my data. SQLite 3. What was the name of the database? USA spending.sqlite.tables. Okay, it's gone. All I have is recipient and transaction inside here. So their SQL injection actually worked in this case. But people, I mean, this is a really well-known thing. So when people write queries that other people, especially people on the web, anyone in general on the web can use, they use special string formatting to say, no, this can only be inside this value. So there are plenty of ways to prevent it. But this class is not about making those sorts of considerations. It's just kind of a fun thing to know about what's out there. Any questions on that? What happened? No. So for you, if you're writing your own query in a file on your own laptop, then you probably don't have to worry about a SQL injection attack, unless it's from yourself or your spouse or your partner is a hacker who wants to mess with you. Yeah.
I want to incorporate some data sets from other sources.
Oh. If you want to incorporate data sets from other sources, then you'll have to load them into the SQLite database if you want to. Everything has to be in the same database to do joins and selections and those types of things. So you can load external files into your SQLite file. It's pretty similar to this. I think it's db write table is the function, maybe. But yeah, that's how I built this database anyways. Other questions?
So when you write to the database, will it change it for everybody or will it only change your?
So I downloaded a local copy of this It's just a local file on my machine that I've changed now. So I've changed this. I will have to add the agency file back in or download another version of the database. Yep. Yeah, so if you do this thing and mess up the database, don't worry, you're not going to ruin it for everyone else. Okay, we'll have office hours today and see you next week.